Hello. In the following example, I want to graph y equals 3 times the square root of 2x plus 3 minus 1. Before I can do anything here, I need to actually convert this form of the equation into something that's slightly different. The reason I need to do that is because what we actually see is when we combine everything, we have y equals a times f of b times x minus h plus k. Basically, the reason I need to change this function is because I need to have the number in front of x to be a 1. And if I do need a coefficient like this in front of the x, I need to factor that out of every term inside of this parentheses. Therefore, I'm going to factor out a 2 from underneath this radical. And what that does for me is it gives me the equation y is equal to 3 times the square root of something minus 1. Now notice all I've done here is I have rewritten what I have here, just I haven't written down what's underneath. If I factor out a 2, I still have the 2 in there and then a parentheses. And whenever you factor out a 2, you divide both terms by 2. So 2 divided by 2 is 1, which is what's going to give me an x right there. And then plus 3 there means plus 3 divided by 2, or plus 3 halves. Okay, this is what I'm actually going to be graphing. Now, think about what we have here. We have a radical, and the parent function for all radicals, or at least an even radical, or at least the square root, is y equals the square root of x. And remember, the domain here is 0 to infinity. And the reason why is because whatever is underneath the radical must be greater than or equal to 0. And if you needed to, you'd be able to solve. In this case, you don't have to, so that's how you know that's what you have. And again, that's why on the xy table, I actually start out with 0, because the square root of 0 is 0, and that's the lowest value of x that I can use. The next value of x that I want to use is 1, because the square root of 1 is 1. The next one I want to use is 4, because the square root of 4 is 2. And the next one I want to use is 9, because the square root of 9 is 3. So there you go. Now I want to work left to right here, which means the first thing I come across is that 3. So I need to use that 3. Now the 3 is on the outside of the radical, which means it's not directly associated with the x. So that means I do what it says, and it affects the y value. It says 3 times the square root, therefore I'm going to do y equals 3 square root of x, which means I'm going to multiply the y value by 3. That gives me a new xy here. Now, because it's multiplying the y value by 3, that means that the x values will all stay the same. So I still have 0, 1, 4, and 9. Now, if I multiply all the y values by 3, 0 times 3 is 0, 1 times 3 is 3, 2 times 3 is 6, and 3 times 3 is 9. I keep working left to right here. Now, from left to right, I have the 3 first, followed by this 2. So that's what I need to look at next. So I'm going to say y is equal to 3 square root of 2x. Now, if there wasn't anything else here, I could just leave it like that. This 2 is on the inside of the radical. That means that it affects the x. And because it affects the x, I do the opposite of what it says. Therefore, I need to divide, because it says multiply. Divide, it's affecting the x, I'm going to divide the x by that number there, which is 2. Now remember, dividing by 2 is actually the same thing as multiplying by a half. When I do that, that'll give me a new xy table. And if I'm dividing the x, that means that the y values will all stay the same. So I'll still have 0, 3, 6, and 9. But 0 divided by 2 is 0. 1 divided by 2 is 1/2. 4 divided by 2 is 2. And 9 divided by 2 is 9/2. We continue working left to right here. The next thing that I see is that positive 3/2. So I'm going to have something that looks like this. Y equals 3 times the square root of 2 times x plus 3/2. By the way, notice that if I distribute that 2, that gets me back to the 2x plus 3 here. So this positive 3/2 is on the inside of the radical. So because it's inside the radical, that means it's affecting the x value, which means I do the opposite of what it says. Therefore, I need to subtract, because it says add, 3/2 from, and because it's on the inside, it's affecting the x value, which gives me a new xy table. Again, because it's affecting the x, the y values will all stay the same. Therefore, all of these still are 0, 3, 6, and 9, but the x values change. So 0 minus 3/2 is negative 3/2. 1/2 minus 3/2 is negative 2/2, which is negative 1. 2 minus 3/2 is the same thing as 4/2 minus 3/2, which is 1/2. And 9/2 minus 3/2, well, 9 minus 3 is 6, so that gives me 6/2. But that's the same thing as 3. Now, if you need to, I can actually go by halves on the x-axis, or you can guesstimate where the halves are, because it's always just halfway in between the two hash marks. Just so you can see this clearly, I'm going to go by halves. So that's negative 1 there. Oh, yeah, I'll go by halves. Negative 2 there. Negative 3 there. Negative 4. And this will be 1, 2, 3, 4, 1. Oh, whoops. I got off a little bit over here. Let me put that back where it needs to be. There we go. Negative 3, negative 4. There we go. Okay, so those are the x's. Now, I'm not completely done because I still have this minus 1. So I need to go ahead and do its table. And because of that minus 1, I'm going to have something that looks like y equals 3 square root of 2 times x plus 3/2, and then minus 1 outside the radical. And notice that I'm very clear that it's outside the radical. Because it's outside, that means we do what it says, and it affects the y value. Therefore, you're going to subtract 1 from the y value. And that'll give me a new xy table. Now, because it's affecting the y values, all these x values stay the same. Therefore, I still have negative 3/2, negative 1, 1/2, and 3. But I subtract 1 from all these y values. So 0 minus 1 is negative 1. 3 minus 1 is 2. 6 minus 1 is 5. 9 minus 1 is 8. Notice all these are integers. So I'm going to go ahead and keep my y-axis in multiples of 1. And you can either write, I'm going to write that down specifically here. So notice that I'm going by 2's every 2 hash marks here. So 2, 4, 6, 8, and so on and so forth. So I'm going to go ahead and graph these points. Negative 3 halves, negative 1. Negative 3 halves is negative 1.5, and then negative 1 will be right there. Negative 1, positive 2 will be right there. 1/2 is right here, and then I go up to 5. And then 3, positive 8. There you go. And then just connect these with a curve. And that's it. That's how you graph y equals 3 times the square root of 2x plus 3 minus 1.